Let's take a look at a new topic. Still on rational functions, but we're going to look at how to find stationary points for our quadratic rational functions. And we're going to use something called the discriminant. You should hopefully know this already from A-level maths, but let's do a bit of a recap. Like, essentially, if you were trying to solve a quadratic, you could use the quadratic formula, and within the quadratic formula, there is this b squared minus 4ac, and that is what we call the discriminant. Okay, because essentially that tells us the number of solutions our quadratic has. And it's also going to help us with stationary points to figure out where the stationary points are. All will become clear in a minute. Okay, so consider if that was our x-axis and that was our quadratic, can we see that in that situation we get two roots, we get two solutions, two values of x, two solutions where it equals 0. So in that case, b squared minus 4ac would be greater than 0, because when it's greater than 0 inside the square root, you add a bit on, you take a bit off, and you get two solutions. Okay? At this point where it's a tangent, it only touches it once. That's when b squared minus 4ac is equal to 0. So if you think about it, right, if that part was equal to 0, you'd add 0 on, you'd take 0 off. So actually you'd only get one solution, wouldn't you? Your one solution would be minus b over 2a. So when that bit equals 0, it doesn't matter if you're adding it or taking it off, it just leads to one solution or one root. And in this last situation, when you've got a quadratic like this, and there's our axis, we're not going to get any solutions. Like, this quadratic does not equal 0, does it? There's never any roots. So that's when b squared minus 4ac is less than 0. Because if this was ever less than 0, inside that square root, you'd have a negative value, and you wouldn't get any real roots anymore. You'd get complex roots. But for now, we're not going to worry about complex numbers. Like, we'll just say that when it's less than 0, no real roots. In other words, they don't intersect each other. The graph does not intersect when y equals 0. It doesn't intersect the x-axis. Okay, so how is that useful for finding stationary points? If you consider we've got some sort of rational function, right? At some point, the rational function might do this, which is a stationary point on your rational function. Now, if we consider y equals k, so like a general line, y equals k, remember, y equals lines are just horizontal lines. So by saying y is equal to k, different k values, say for example if y was equal to 1, if y was equal to 2, and if y was equal to 3, different values are going to give us different numbers of solutions, or different amounts of intersections with our original curve. There's our rational function. Obviously the rational function might be trapped between asymptotes and there'll be other stuff going on, but we don't care about that. Let's just focus in on the part of our rational function where the stationary point is. Okay, so the way that we do this is we set y equal to k and y equal to our rational function, and then we set those two functions equal to each other. So we'll end up with your rational function equal to k. And if we rearrange this, we can think about how many solutions this equation has. Now, if we're looking for a stationary point, can you see that there's going to be one special y value that we're trying to find, where at the stationary point, the line y equals k will only touch the curve once. So once we've done some work with this equation, we will then think about the discriminant. And the key to finding the stationary point, that's when you only get one solution. So when your rational function and your line only intersect at one point, in other words, when the discriminant equals 0, you figured out where your stationary point is. Okay, quite a bit conceptually going on here, so maybe pause and rewatch that, but I think the best way for us to do this is we just try an example and you'll see what we have to do. Okay, so I'm going to try something a bit different. Hopefully that's readable. And we're doing example 2 from the booklet. We've got a rational function, which is x squared plus 4x divided by x squared plus 9. And we're thinking about, first of all, the asymptotes, and then we're thinking about, it mentions roots in the question. So like if you see something that says equal roots, straight away you should be thinking about the discriminant. Okay, so if you've got two equal roots, that means your discriminant's equal to 0. In other words, there's one root. There's a couple of different ways you can phrase it. It might say it's a tangent, or there's just one repeated root, but equal roots is leading us down to discriminant, and it wants us to find the two stationary points. Okay, so let's start from the beginning. So it says the graph has an asymptote which is parallel to the x-axis. What's that mean? Parallel means same direction, so the x-axis is like this, isn't it? So if we're parallel to the x-axis, what type of asymptote are we being asked about here? It's got to be the horizontal asymptote, hasn't it? It's just like a fancy way of saying, what's the horizontal asymptote? Parallel to the x-axis, horizontal, isn't it? So we could see that we've got y equals x squared over x squared, and then the other stuff doesn't matter, so I can just quickly write y equals 1. If you want to do your cancelling down, divide by x squared, that's also fine, that'll give you a method, but you could just write y equals 1, you'll get the answer. Part B, explain. Okay, so it's quite difficult question to get the marks in the exam. Like if you have to explain something, like I know it's a maths exam, but we actually have to write some words here. Explain why the graph has no asymptotes parallel. Again, we've got to interpret what this means. No asymptotes parallel to the y-axis. So just think, maybe you can visualize this, or you could do a quick sketch to help you. Y-axis is like this. If I'm parallel to this, it's basically asking me about the vertical asymptotes, isn't it? So we've got to explain why there's no vertical asymptotes. So with an explain question, you can do some maths to back up your explanation, but you also got to write some words. So let's just look at what happens. So for a vertical asymptote, our denominator, which would be x squared plus 9, we'd be thinking about when the denominator equals 0. Hopefully we can look at that and say, actually, that's not going to have any real solutions, is it? Because you've got something squared, which is positive. When you square something, you get a positive answer. Well, greater than or equal to 0. Plus 9, clearly that's not going to give us 0. So we could say, you could go a little bit further if you want to make it clear, say x squared equals minus 9. You could even say x equals plus or minus square root of minus 9. But at some point we'd have to say that this equation has no real roots. So the denominator does not equal 0. And then we can be fancy and do like 3 dots, that means therefore no vertical asymptote. Okay, and that should be enough. Do a bit of maths, but back it up with some words. Okay, now part C is a show question. So when we've got a show question, we're aiming to end up with this as our answer. So we're trying to get to 9k squared minus 9k minus 4 equals 0. And it says f of x equals k. So we're not using y notation, we're using f of x, but it's the same. So essentially what we've got is f of x is equal to this, and f of x is equal to k. So, you can use y if you're more familiar, it doesn't really matter. So we're thinking about when y equals x squared plus 4x divided by x squared plus 9, and we're thinking about when y equals k. So when these two things intersect, remember it's leading us into our stationary point, like y equals k, if that only intersects the function once, that's when we get our stationary point. That's when b squared minus 4ac is equal to 0, when we get one solution between k and the curve. Another way of saying that is two equal roots. Like if there's a repeated root or equal roots, your discriminant will equal 0. And there's a lot of interpretation on this question, guys, so it'll take a bit of practice. But think about it, if I had x minus 3 all squared, if I was drawing that graph, that would just have a repeated root at 3. And if we expand that out, x squared minus 6x plus 9, if you did the discriminant on this, b squared minus 4ac, you'd end up with 36 minus 36, you'd end up with 0. So if your discriminant equals 0, you know that you've got 2 equal roots, or maybe another way of thinking about it is 1 repeated root. Okay, so now that we've interpreted the question, how are we going to get to this answer here? Okay, so this answer, as if by magic, is just a load of k's. We're thinking about when these two things intersect each other, so set them equal to each other. Okay, then we want to rearrange. Before we can think about the discriminant, we need to rearrange this into a quadratic. Multiply up. So we've got kx squared minus x squared minus 4x plus 9k. So first step, set them equal to each other, rearrange. Another useful thing, right, because you're thinking about it as a quadratic, take out your factor of x squared, so we've got k minus 1. So that's my x squared coefficient, we've got minus 4x, and we've got plus 9k. So now we need to be able to look at this and realise we're in the world of quadratics. So that's A, that's B, and all of that is C. Remember, it's the coefficient of x squared is A, the coefficient of x is B, and the constant that you're left with. Don't forget k is just a constant, so we just don't know what it is. Like, it's a number that we're trying to find, and that's going to tell us where our stationary point is. So we've got a quadratic, and we know that at this stationary point, we know that b squared minus 4ac is going to equal 0. So let's do the algebra and see what happens. Okay, so b squared make sure you use a bracket. Oops, sorry, b squared, it's b is minus 4, not minus 4x, you don't need the x, it's just the coefficient that we're looking for. So it's minus 4 squared, minus 4a, which is k minus 1, and c, which is 9k. So we've got 16. Be careful when you multiply these three things out. I would be tempted, if you're going to do the minus 4, make sure you times both of these by minus 4. I'd probably be tempted to times both of these out, and then multiply everything by minus 4 at the end, so that'd be 9k squared minus 9k. Okay, so we've got 16 minus 36 k squared plus 36k. Look at what we're aiming to end up with, because it's a show question. Like, the good thing about these show questions is even if you can't quite get there, we can use this for the next part of the question as long as we understand how to use it. But we're aiming for a quadratic in terms of k. We've got a quadratic. We just need to divide everything by minus 4, and then that will give us the positive 9k squared minus 9k minus 4. Alright, part D then finally mentions the actual stationary points on the graph. I know I've said this a couple of times, but there's a lot going on. These k values, y equals k, don't forget, these values that we're trying to find when the graph touches once, in other words, when we get one solution, when the discriminant is equal to 0, are going to be solutions to this equation here. So this equation here is going to tell me what k is. But don't forget, when you know what, once we've solved this to figure out what k is, we also know what y is. Like, this is like a nice way of getting our y value for our stationary points. If y is equal to k, once we know what k is, we know what y is. So we're nearly there. We've nearly got our stationary points. We've just got to figure out what k is, and then we know what y is. And once we know what y is, we can figure out what x is as well. Okay. So quadratic, does it factorise? Hopefully it does. Don't really working with thirds at this point. Let's try 3k and 3k. Factors of 4, 1 and 4. We want minus 9, so if I give that, that'll give me minus 12. Plus 3, yeah, okay. Use your graphical calculator to check, or even the quadratic formula. But that would give me the solutions that we're after. So k would equal minus 1 third. And k would equal 4 thirds. I'm just going to check I've done that properly. I did that quite quickly. 9k squared minus 4 minus 12 plus 3, yeah, minus 9. Okay. So now that we've got the k values, therefore we know our y values. So y is equal to 4 thirds and y is equal to minus 1 third. Last thing to do, because we want the stationary points, figure out what x is. So we have to go back to our graph. Remember, this is a point on our curve that we're trying to figure out. So if y is equal to 4 thirds, we need to rearrange to solve to figure out what x is. There is actually a slightly quicker way of doing this, but I've rubbed off my working out. Earlier on you'll have had some working out with x's and k's. If you sub it into that, it would be quicker. Just wait there 1 second. Okay, so instead of subbing it into this, you could do that, it's just a little bit of extra work. See this equation here, you probably want to highlight this. So that one there is what we can then, as long as we know what k is, sorry, if we know what y is, in other words we know what k is as well, we can sub it into this, and that will give us a quadratic that we can solve straight away. So if k is equal to 4 thirds, that would give me 4 thirds minus 1, so it would be 1 third. X squared minus 4x plus 9 times 4 thirds, which would give us 12. Okay, so we're working with a quadratic. Remember, we just need to figure out what x is. We're only expecting to get one value, by the way. We'll see what happens in a second. We know that y is equal to 4 thirds, so we just need to figure out what x is. Multiply it by 3 to avoid the fraction. X squared minus 12x plus 36. And at this point, I know there's a lot going on, but at this point you'll know if you've done it right. It's quite a nice feeling, because you end up with x minus 6. This quadratic that we're left with should only give us one solution, because there's only one x value that matches up with that one y value. So our first stationary point would be 6. 4 thirds. I'm not quite sure why I'm writing in purple, but there we go. Let's try the last one. So if y is equal to minus a third, then we can sub it in. So that would be minus a third, minus 1, so that would be minus 4 thirds. X squared minus 4x. Minus 9 over 3, so that would be minus a third times that, so that would be minus 3. Again, we're just trying to figure out what x is. Multiply by 3. I'm going to multiply by the minus in a second. So that would be minus 12x. So we've got 4x squared plus 12x plus 9. And again, easy to spot if you've done this right, because this will factorise into a bracket squared. It would be 2x plus 3. If you're not confident, write it as 2 brackets, but if you expand that out, that'll take you back to this. Again, at this point we know we've done it correct, because you only get one solution. So our two stationary points are minus 3 over 2 minus a third and 6 4/3. Okay. Got to be good on your algebra with this, and I would recommend that you definitely practice quite a few of these, because think about trying to do this in the exam situation. Like you've got to be confident on this, and you've got to be accurate to be able to work quickly enough to do this. Alright, but hopefully that was useful, guys. Thank you.